So, ladies and gentlemen, what I'm going to do today, rather than go through the lecture notes are uploaded on Eve. It's there. You can read through it. But I know that you all know how to read, right? You all know how to read? Yes? So I'm not going to go through the slides with you. I am going to jump straight to the programming aspect so that we can work through this together. Okay. What we are going to do today is effectively show you how to do if statements differently. You all know how to do if statements already, right? What do if statements serve? What purpose do they serve? They provide you with selection, right? So in other words, if a person does a certain something, or if the conditions are a certain so and so, then your computer program must respond in a different way. Does this make sense? All right. And up to now, you know how to solve this problem by using if statements and only if statements. Sure, you know how to do different types of if statements. In other words, you do your normal if statement, which is like separate if statements on their own. But you also had to do nested if statements. Do you remember that? Okay. Now, today, what we are going to do is we are going to do a different type of selection. Just like with repetition, you had while loops, remember? And then you could also do another type of repetition using for next loops. The same thing happens with if statements. You can do selection with if statements, but you can also do if statements with what we call a select case statement. Okay, select case. Now, VB calls it a select case. But for those of you who programmed before, you will know it as a switch statement. Right. So who knows what a switch statement is? Or perhaps, you know, you do computer science, they've done switch statements already, yes? Okay, right. So we are now going to do the VB version of a switch statement, which is called a select case. Okay, and the way I'm going to do it is I'm going to start off with this very, very basic problem, which you must all know how to do. Okay, all of you. And this question is going to feature very prominently in your semester test or in your exams. And that is, if you are given a number, can you tell me whether it's even or odd? Does that make sense? Okay, so in other words, you might be given, and obviously it's not going to be as simple as this program that you see in front of you, which is very ugly, okay? But I'm not here for beautiful aesthetics today. I'm here just for functionality. When you have to write the semester test or the exam, please don't hand me this horrible form. If you hand me a horrible form like this, which says Form 1, Button 1, you can be guaranteed you're getting 0% for the 2% that you get given for an interface. Right. So if you all want to know how many marks do you get for having a beautiful user interface, 2%. And you're like, 2% only? Yes, 2% only, because you're not here to make things beautiful. You're here to solve problems. You're here to write code. But let's be truthful here. How many of you will care very much about that 2%? Anyone? Okay. Physical people, lots of hands up. Online people, yeah. Okay. Okay. Right. So, don't do this, obviously. But this is just a point. So the idea is, in a typical semester test question, you will be asked to calculate a bunch of things. Maybe if we build up from last week's problem where we said, okay, we need to work out the total number of vaccinations per vaccine type. So let's say you work out a total, and taking that total, now my question is, if it is an even number, then do this. And if it's an odd number, do that instead. All right, so that's typical. Not ask someone, please enter an odd or even number, and then we will decide whether it's odd or even. There will be some calculation, and then based on that calculation, your program needs to respond in a certain way. So maybe if it is an even number, now total number of vaccines is an even number, then it means, oh yay, good, because this type of vaccination needs 2 shots. And now you see the total amount of vaccines is an even number, meaning that people have taken all the vaccinations. If it's like, you know, everyone must take 2 shots, but now hang on, it's an odd number. It means, hang on, someone didn't take a vaccine. Does this make sense? Something along those lines. Okay, so let's take a look at this question. So the idea is, ideally, we are going to have our user enter a value in that text box, a number. You're going to press this button, and when you press this button, it's going to determine whether the number the user has entered in the first text box is indeed even or odd. And based on that, it's going to give a response there. And that response for today, to keep it simple, is it's just going to provide a text output that says even or odd. All right, does this make sense? Very simple. Obviously, not the same thing we're doing in a second semester test. There will be other calculations based on whether you've established it's even or odd. Okay, however, how do we do that? Now, if I speak to you and I say, hey guys, I'm going to give you a bunch of numbers, and then based on those numbers, you tell me if it's even or odd. Okay, so I go 100. 100. Is 100 even or odd? Even. Okay. What about 17? What about 1,562? Ooh, you guys are smart, eh? Okay. How about let's see, 23,562,000,000. Oh, you see, now it's like a Jacob Zuma situation, and like 300,000 and 22,000 and 103. You guys are good. Okay, right, no. So my question is, wow, you guys are good. You know how to tell. Okay, now I want you to tell the computer how to tell. Well, how do you know that a number is even or odd? Now we're going to tell a computer how to do it too. So what do you guys do? Do you memorize every single number in existence? No, okay. Because if you did, then, you know, that makes sense, right? So how did you figure the number out? Whether it was even or odd? Like, what did you have to do? Okay, and I think you all have like little tricks, right? Okay, so what are those tricks? Because we've got to translate that trick into program. Okay, now I'm going to start off by using if statements. Okay, so I'm going to show you how to write the if statement version of this. And then I'm going to show you how to take that exact same if statement and convert it into a select case instead. All right, so obviously I'm going to have a button there. All right, so we've got some answers where Carol Marab is saying if the last digit is either 1, 3, 5, or 9, the number must be odd. And then Ari Mavungu is saying if it's divisible by 2, it's even, else it is odd. And then you've got some like starting people go, oh yeah, but you can use the mod function and blah, blah, blah. Okay. And wow, there's some interesting answers here. But basically they're saying the general consensus is a number is even if it is divisible by 2. Does that make sense? That's what you've been doing, right? Or rather, let's be honest, you're not really dividing by 2. You're not dividing anything by 2. You're just going, what's that last number? Right? Okay, it's fine. Okay, but now, obviously, maybe one thing you would do is, let me just check, 150, can you all see? Is it large enough for you? Okay, so I'm going to start off with a variable. I'm going to have local variables in my example, all right? So dim input num as integer, okay? And then I'm going to say dim result as string, okay? And then I go input num is equal to cint text box text box 1. You can see how terrible this is. I haven't named anything. So obviously the first text box is text box 1. And now obviously the text box 2.text is equal to result. Okay, so the idea is in between here, in between getting the result, from the value from the user, I'm going to do some magic. And based on that magic, I'm going to get an answer, and I'm going to pop that answer into the second text box. Easy peasy. Now it's about the logic. And we've all said, well, if we can divide it by 2, if it divides by 2, then we know that it is even. But if it doesn't divide by 2, then we know it is odd, right? Does this make sense? Turns out, ladies and gentlemen, that there is, as some people have mentioned, that you can use something called the mod function. Okay, now mod in maths is basically the modular function, which actually is, do you remember back in primary school where you had to do long division? You remember that? Where you took a big number and then you drew a kind of like a roof over it, remember? And then you put a number and then you do a division, and then when you work it out, you eventually maybe you get a remainder. Do you remember that? And then you will write down remainder, say 5, right? Okay, the mod function basically does that. Okay, the mod function is interested in you dividing two numbers, basically. And what it does is it says, when you divide this number, we're not interested in the answer in terms of, for example, if you say 10 divided by 2, all right? 10 divided by 2 is 5. Okay, so the answer is 5. Remainder what? 0. Okay, the mod function doesn't care about the 5. Yes, it does division, but it's not interested in the answer of how many times does 10 go into 5. I mean, go into 2. Well, I can't even remember what number is it. Okay, what it's interested in is the remainder portion of your division. Okay, so let's look at this. I am going to declare another variable, and that is, I'm going to call it remainder, can't spell, remainder as integer. And I'm going to go remainder, and yes, if it's green, it means I haven't actually used the variable or the yet. Okay, obviously. But now I've just said remainder is equal, so it goes, no more squiggly green, because you're using the verb. So the remainder is equal to input num mod, okay? So this is very different in terms of a function, because how do you often use a function? You would call the function name, and then in brackets, inside the bracket, you would provide it the values you wanted to work out. Does this make sense? But this one, this mod is actually more like a mathematical operation. It's an operator. So you know how if you want to divide things, where you say, let's say remainder, remainder is equal to 10 divided by 2, right? So that divide is an operator. We're doing the same thing with mod. Mod is effectively an operator. And we go divide by 2. Okay, now remainder is equal to input num mod 2. Why mod 2? Because remember, we've established that if anything divides into 2, and it gives us, if it divides into 2 perfectly, so in other words, no remainder, it would mean it is a even number. What is the other possibility when you divide anything by 2? What is the other possible answer? You can either get a 0 remainder, but you can also get a 1 remainder, right? You can't get a 2 remainder, can you? You can't get a 3, 4, 5, 6. Does that make sense? Okay. So you go remainder is equal to input num mod 2. Now I'm doing it in a very long way. I know some of you are already going, but can't we compress this into a single line? Sure, absolutely. You can compress this into a single line, but I'm just going through step by step what we're doing. So we're saying input num, which is the number that the user provides us, 7, 17, 1 billion, blah, 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 right? And you go modify 2. Okay, So note, I'm not interested in how many times it divides into 2. I'm only interested in the remainder portion. And that remainder portion, basically, I would say if remainder is equal to 0, then result is equal to even. Else, does it make sense that you use else? Because it can only be 0, or which is even, or it is odd. Okay, a number is only even or odd. It's not sure. Okay, so your result is equal to odd. Okay, so let's actually run this and see how it actually works. Okay, now my laptop is taking its sweet time. Okay, there we go. Let me move this here. So let's give it a number. So let's give it an even number, which we all know 8, you agree, is an even number. Okay, when I press this button, it goes even. Ooh, okay. Right, so let's try something different. Let's try 11. Okay, I know, 111. Because, you know. Oh, odd, okay. Maybe it's cheating. Okay, maybe it's 11118. Let's see that. Okay, so it does a pretty good job. Okay, so it's nothing special. Would you say that this actually makes sense? Okay, now I'm going to close this program, go back here, and you can see, okay, so this was the if statement. Can we make it simpler? Obviously, we can make it simpler. We can say if, and instead of having this remainder here, I could have actually taken this, right, and replaced that over here. That would also have worked. Right, nothing magical. All I'm doing is, instead of taking an answer and storing it in a remainder variable and then taking that variable and doing the comparison, I am doing it all in one go. All right, so some of you might go, oh, I'll do that. Or some of you are like, no, I won't do that. Another thing you can do is you could perhaps take this and put it into a function. Does this make sense? All right. How would you do that? Well, obviously, with a function, you would need to go private function is even odd. Or maybe let's just go is even. Okay? So in other words, I'm going to create a function that will return a true or false answer. Does this make sense? That will say, if it is even, that's what the function name says, is even. If it is even, it will return true. But if it's not even, it will go false. Okay. So what does it need? It needs how many arguments? How many parameters does it need? How many? So here is a function that's going to determine if a number is even or odd. How many values do you need to give it so that it can do its job? Do you need 2 values? Do you need 1 value? Do you need 6 values? You only need 1, don't you? Okay, so I'm going to go by val input as integer because it's obviously an integer number that's going in. And then because this is a Boolean function, in other words, it's going to return either true or false, I am going to put in as Boolean as the return type. Okay, so over here, I'm going to take this and I am going to do the following. So here, I can keep it really, really simple. Okay, so remember, nobody's going to go, hey, you know, you could have written this in 1 line of code. Why'd you write it in 4? Nobody's going to argue that. Okay, as long as it works. What I'm going to do is I'm going to be super lazy and I am going to do it in a single line. Not to show off, but to show you all that it can be done. All right? Right. So what have I actually done? In a single line, I've basically done the following. I took the parameter and I modified 2. And I said, take that, once you've modified 2, is it equal to 0? And I said, return that. So what is happening here is it's performing one calculation, right? Specifically, input mod 2, taking that number that the user provided, modding it by 2, and then that does a calculation. But this input mod 2 equal to 0, okay, is basically a comparison. Okay, so I'm saying, you know that answer that you got from input mod 2? Is it equal to 0? That's basically what I'm doing. Is it equal to 0? And when I go equal to 0, it can either give me a true or false answer. Does this make sense? Because this part is this answer equals 0. That's all you're saying. This answer equals 0. I know, it's very rude. You're not even asking politely. You're not going if it is equal to 0. You're just going equal 0. Okay? Okay, I'll get to you now. Right. And then I'm saying that return the answer. Return whether it's true or false, that this is equal to 0 or not. Okay, so if you're sitting there and you're like, no, I can't see this happening, it's okay. It's not the end of the world. Go and write it the long way. Nobody's going to go, oh, look at who wrote it the long way. So losery. No, as long as it works. Okay. Okay. Am I a fan of doing it this way? Depends on my mood, really. Okay. I'm not that big a fan of it, honestly. Sometimes I'll feel, oh, yeah, I'll do it this way. Just go, oh, I can do it in one line. For teaching purposes, I really prefer to do the following, and that is, I would say, maybe I would go dim on or remainder. I'll put the remainder here is equal as integer. Okay, and then I would say remainder is equal to input mod 2. All right, and then I go if remainder is equal to 0, then return true, else return false. And I know some of you are like, oh, this is so long. Okay, but that's okay. Nobody's going to go, wow, why is it so long? Because it does the same thing. Okay, but for those of you who are like, well, I like that one single line, only use it if you are comfortable with the single line approach. Okay, and I see I've already got a question there that goes, what does input mod 2 do? Can anyone online? Ah, okay, Kara Marava is actually answering. Okay, thank you. And you all understand what input mod 2 does. You sure? You're still following? Okay. All right. So notice that I go return true or I go return false. Again, it's just an if statement there. All right. Now we're trying to say, well, yes, it returns the remainder portion only. Okay. And with the return, remember, the way the function works is if you use the return command, it will return whatever value you wish to return. What is the alternative to using the return command? You would say is even is equal to true or is even is equal to false. Does this make sense? Okay, right. Now, if I do want to use the is even, then obviously I will comment that out. I will comment that out too. And I would have a dim is even result as Boolean because I need to store that. And then I will call the function is even result is equal to is even input none. So there I'm calling the function. Does this make sense? Obviously, because it returns a true or false, I can't then just say is even result, because if I did that, would this be very helpful? And I think I would keep it this way. I will run this now and show you. Okay. So you notice that I actually just got a true or false answer. I worked it out from the function, and I am going to display it. So let's try 6. Okay. True. This happens in semester tests and exams, where the student goes, they have to write a function which returns true or false, so they do that, and then they output that true or false to the text box, and I go, no marks, no marks for display. Why? Is it because I'm mean? if you are a user and you're expecting an answer in the second text box, which tells you whether the number is true or false, well, even or odd, what does true mean to you? Does true mean anything to you? That's like saying, would you like cake? True. Are you female? True. Are you undergrad? False. Huh? Okay, so when you've got code like this, where the question specifically asks you to write a function that returns a true or false answer, but you've got to display a meaningful result in your text box or in your UJ grid, you've got to write another if statement. Okay, so over here, instead of going is even result, you would have to do the following instead. And that is, you would have to write another if statement here, and you go if is even result, then even, then else text box 2 dot text is equal to odd. Or you could actually use result. I suppose I can use result there. And so result is equal to even, result is equal to odd, end if, and then you've got this is equal to result. Okay, now notice how my statement here, my if statement. Now normally with an if statement or with a while loop, we remember there's a condition there. Your condition is normally something equal to something, right? Yet here, I'm going if, and it's just a variable. Single variable on its own. No equal. So how does this work? Remember that when you go if something equal to something, what is the result of that if something equal to something? You actually either get a true or false answer. Does this make sense? That's the whole point of a comparison. I am choosing not to use an equal here because my variable already contains a true or false result. Does this make sense? It contains a true or false answer. Because remember, even result is even returned a Boolean array. So already I know if it's true or false. So in a way, this is again another type of shortcut where you go if is even result. So remember it returns a true, right? Or it returns a false. Does this make sense? Okay, if you really are not that comfortable with this, and I see that some people are like, whoa, so many shortcuts. Again, if you're not comfortable with it, nobody's going to go, wow, why do you need to do this? If even result is equal to true, then the result is even. Does that make sense? Okay, so you can go with this. You can go with either one. You can go with. Now, which one is safer? This one, definitely. This one is definitely safer because this is less abstract and compact, and you're like, less words. Maybe you have, and you know, in a way, you know, the less words there are, the more you actually have to think about it. Go, Okay? So if you're not comfortable with that, stick to this. Stick to this approach instead. Okay, now this is basically using if statements. But we want to know how do we convert this if statement into something more other way, which is the select case. All right, so the select case works as follows. Now please note, an if statement does not exist within a select case, okay? You use either of the two. But you can combine them. So you know how you have if statements inside other if statements? Do you remember that? You can also have if statements with select cases inside them. Or vice versa. You can have a select case with if statements inside. But that looks really messy. Okay. And you've got to be comfortable enough to know both of them so that you can start mixing the two on request from us. So in the semester test and exam, we may ask you to write a selection code. So just so you all are on the same page, there will be a question where you have to design two record structures, one inside the other, all right? You will have to initialize your arrays. You will have to resize your UJ grid. You're going to have to input data from the user. you're going to have to perform some sort of calculation. Maybe it's addition, maybe it's multiplication, maybe it's division, you know, through a bunch of arrays. You're going to have to find a minimum or maximum. And then there's also going to be a question relating to selection. So in other words, there's going to be a condition you have to evaluate, and based on the evaluation, you perform some other type of calculation. And that, in a nutshell, is your second semester test. All right. So how many of you are feeling a little bit more comfortable and go, oh, is that all? Only one hand. The others are like, not that ready yet. Okay. Right. So how do we do a select case? So I will show you the select case here, all right, which will be used to replace this if statement here. All right. Now, this is not the best if statement to show you why you would want to do a select case. The strength of a select case comes in when you're working with number ranges or values that match from a list. But I'll show you that just now. Okay. So, instead of this if statement, which remember is basically selection. If it is this, do this. But if it's that, do this instead. Okay. A select case starts with select case. All right. That's why it's called a select case, in case you're wondering, why is it called a select case? Select case, and then you provided the variable you wanted to compare. So what do you want to compare? You want to compare is even result. Right, that's the variable you are looking at. So in an if statement, what are you looking at? You're looking at is even result. Is it true or is it false? You're doing the same now. So you go select case, and you provided the variable name is even result, and you press enter. Now, because you're in VB, in Visual Studio, and you're not writing theory stuff anymore, you can rely on Visual Studio to complete certain things for you. So immediately it goes, oh, select case. We're going to give you a case, and we're going to get end select. We're going to end the select statement for you. All right, so end select means this is the end of your selection. But it's got a case. Now what the case does is it says, is it the case that if even result is a certain value? So what is even result? It's a Boolean value. In other words, it can either be true or it can be false. So for case, you will now type in true, okay, and press enter. And you notice it goes to the next line and it's tabbed. And this tab basically says, okay, give us the code you want us to execute if it is the case that is even result is true. Does this make sense? Okay, so what happens if it's true? Well, result is equal to even. Is that all? Yes, that's all. You only want that single line of code to be executed if the case is true. But what is the other case? If it's not true, it is false. Does this make sense? So I'm going to go case false, and I go result is equal to odd. And there you have it, ladies and gentlemen. That is effectively that. And you're like, well, you know what? This is more lines of code. Why would I bother using this? This is a very silly example here because it's only a very binary result. When it's a binary result, it probably makes more sense for you to use an if statement. Because you go, if it's this, else, do something else. Right. You don't actually have to go case false. You can say case else. That also works. All right. But when we do that, here's the one rule with select cases. You cannot start your cases with case else and then do the other. Does this make sense? That's like if you were a police officer at a roadblock, right? And you're looking for things. So let's say you are looking for all drunk driving, okay? And you are looking for unpaid parking tickets. and I'm looking for everything else. Okay? So we stand in our queue. Who should go first? Should I go first? No, why not? Because then I arrest everyone, right? Because it's everything else. It should go through either of them first, and I'm the catch-all right at the end. Does this make sense? That's why you see that when you put case else first and then do a case true, there's a squiggly red line and go, what are you doing? Okay, right. So this is an example of a select case, but it's only binary. So let's show you the differences that which will be beneficial if you use a select case over a if statement. So the other example I want to go through with you quickly is, let me take this button and create another button. Okay, and I'm going to click on this button, and what this one will do is I'll go dim input as integer and dim result as string. Okay, and the way this input is going to work is if it is let's try and think of ranges. Okay, so let's think of our marks. So if it's 0 to 49, it's a fail. You know what I'm talking about. Okay, so I'm going to go select case input, remember, because input is the value I want to compare. Does this make sense? Okay, obviously I need to have input as something, so I go input is equal to cint input box give mark, right? And here, case, now hopefully in the back of your mind you already know how to write the if statements for this question I've got. 0 to 49 is fail, 50 to 74 is pass, 75 to 100 is distinction. Got it? Okay. So you would have written 3 if statements, right? Here with the select case, I would have said this. Can't spell. That, ladies and gentlemen, is how you would have done a select case for the range 0 to 49, 50 to 74, 75 to 100. Can you see how if you were to write this as a select case, it's less typing as opposed to an if statement? Because in an if statement, you would have to say, if input is greater than equal to 0 and input is less than equal to 49, then result is fail. Else, if, can you see where I'm getting it? You see the benefits here? Okay, so this is the one way to do things. Another one is, and I'll show you the slides. Let me show you the slides, and then you can see the benefit of that. Is make sure you can see it. You know, hang on, slideshow and current slide. Okay, hopefully, let me see if the online people can see this. Okay, online people can see it. Okay, so over here, you can see that's the one I showed you just now, the range, something to something, something to something, all right? And let me, there's also this one, 1, 3, 5, 7. So in other words, you can list things. Obviously, when you try to find something is even or odd, please don't do this. Okay, do the mod. What I normally do is I do this as an example just to show you can list values. And if it matches, then you can say that. But what happens in a semester test or in an exam is that people give me this code. And then I go, no, 0. Why'd you do that? Okay, this is also another example. Case is less than 0. Case is greater than 0. Case 0. So you can actually, the case is, and then you can do ranges less than, greater than. Can you see it's less typing in all examples? All right, over here, case color, you can see we can do red, yellow, blue. All right, so in other words, here's a list of strings. If you match, give this result. If not, give some other result. Okay, Does this make sense? Obviously, it makes more sense when you try it out yourself. Okay, so there is no two selects. There shouldn't be two n selects. No, remember the n select is basically just to indicate that this is the n of a selection. All right, the n of a selection of a select case. And then you've got your cases as you go along. Now, it's really important that you realize how the select case actually works. The select case finds the first match. Okay, and then jumps to the end of the statement. So if you find that this matches, it will execute that line of code and it will jump to the end of the select. It won't even bother to look at those two evaluations, which is the reason why the case else always has to be at the end. Because if you put the case else at the top, it goes, oh, match, the end, go away. All right. Okay. It is the end of today's lecture, right? No, I've got a few more minutes. No, I don't. Okay. We had so much fun, clearly. All right. This is an example question for you to work through. Please go through this and we will work through it on Thursday. Enjoy the public holiday that is Wednesday. Freedom! All right. Bye-bye. I'm going to stop the recording.